Hello. In this video, we want to look at an application. The cost in dollars to manufacture X graphing calculators is given by C of X is equal to negative 0.005 X squared plus 20 X plus 150 when 0 is less than or equal to X is less than or equal to 2,000. Find the rate of change of cost with respect to the number manufactured when 100 calculators are made and when 1,000 calculators are made. Okay, so X is the number of graphing calculators, and we want the rate of change when 100 are made and when 1,000 are made. Now, if it doesn't say average rate of change, just assume it means instantaneous rate of change, and that's really what we usually mean. So we really want to figure out what is C prime of X here. Well, to do that, we're going to need to know what is C of X plus H. So that would be negative 0.005 times X plus H squared plus 20 times X plus H plus 150. Simplifying, that gives us negative 0.005, and then X plus H all squared is X squared plus 2XH plus H squared. Distribute the 20 there. Gives us plus 20X plus 20H. And then plus 150. Now distribute the negative 0.005. And that's going to give us negative 0.005 X squared minus, now 0.005 times 2 is 0.01, so minus 0.01, and then XH, and then minus 0.005 H squared, plus 20X, plus 20H, plus 150. Awesome. So here is the C of X plus H. Now, to find C prime of X, that's going to be the limit as H goes to 0 of C of X plus H minus C of X, and then all over H. So we're going to replace C of X plus H with all of that right there. So this is giving me the limit as H goes to 0 of negative 0.005 X squared minus 0.01 XH minus 0.005 H squared plus 20X plus 20H plus 150. And then we're going to subtract off the original C of X, which is right here. So that would be negative 0.005 X squared plus 20X, and then plus 150. I'll put it there. Then, of course, all over H. Awesome. Now, the great thing is, first of all, anything that does not have an H will have a counterpart over here. And all of those are going to cancel because we are subtracting one from the other. Now, what's left over, everything is going to have an H left over in the numerator, so I can factor that out. So we have the limit as H goes to 0 of H times negative 0.01 X minus 0.005 H, and then plus 20. And then all over H. Now, notice those two H's cancel. One's in the numerator, one's in the denominator. So we have the limit as H goes to 0 of negative 0.01 X minus 0.005 H plus 20. And now notice that we plug in H to go to 0, so this term goes to 0. We're left with this plus this. So that gives us C prime of X will be negative 0.01 X plus 20. Awesome. Now, That's the average rate of change at any given x value. It wants to know when we have it at 100 calculators and 1,000 calculators. So we just need to plug this in. C prime of 100 will be negative 0.01 times 100 plus 20. Negative 0.01 times 100 is just negative 1. Negative 1 plus 20 is 19. It doesn't say the... Yes, just the cost. Yeah, good deal. That's 100, and then 1,000 is what we want. So C prime of 100 is 19, and now the units here, C is the cost in dollars, and X is the number of calculators. So this would be dollars per calculator. Now the rate of change at 1,000 would be negative 0.01 times 1,000 plus 20. Negative 0.1 times 1,000 would be negative 10. Negative 10 plus 20 is 10, and then dollars per calculator. And there you go. Awesome. Come on now. There we go. Awesome. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.